what causes the seasons. So this movement of the earth, the people say it is going around the sun. After Copernicus, the guy Kepler came and said it is not a round, going around in a circle is not the correct approach. It is going on an ellipse. Ellipse is like a egg-shaped circle. Okay, so that triggered the imagination of many people. So then what causes seasons? I saw that some people actually are giving me very nice answers. Okay, so look at this answer. It's an interesting answer. Okay, how are seasons caused? That is the question. The answer is that since Earth is in an elliptical orbit around the sun, it is sometimes nearer and sometimes farther. Elliptical orbit is a egg-shaped orbit. So whenever it is nearer to the sun, it is summer. Whenever it is farther from the sun, it is winter. Nice argument. Okay, so let's look at this argument. But the question is, do you agree with this argument? So let us just see whether this is a correct explanation of seasons. So now let us look at the elliptical orbit itself, Earth revolving around the sun. Okay, look at this. Now you have, let us say, Earth, the sun is in the middle, and Earth is there on the elliptical orbit, and it, let us say, goes around like this. So when it goes around the sun like that, you can see that it is nearest when it is that side, and it is actually farthest when it is that side. Nearest is summer, farthest is winter. Is it a good argument? Is this correct? So apparently, let us see whether it is correct or not. Yeah, if this is correct, then there must be 2 summers and 2 winters. You know why? The nearest is twice and farthest is twice. So summer, winter in 1 year. Does it happen? So our observation that it is just 1 summer and one winter in a year tells us very clearly that this theory of ours wrong theory. Okay, let's dismiss this theory. Okay, this is not how our seasons happen. Okay, so what else can we say? So first we have to understand before going further, this difference between the circle and the ellipse. Okay, this is basically the circle. Okay, circle has 1 radius. Okay, 1 center, and if you look at the ellipse actually has 2 centers and 2 radiuses, or 2 radii. That's what we call. Okay, so we call one of them as semi-major axis, another one as a semi-minor axis. 2 of them. Okay, where is the sun? So now, if it were to be basically a circular orbit, we could say sun is at the center. Okay. And if it is the elliptical orbit, where is the sun? There are 2 centers. Or is it in between those 2 centers? Where is the sun? Okay. So in reality, the sun is actually at one of those centers, not in the middle. It is in one of the centers. If you see the distance between that one center and the other side actually is 14.7 crore kilometers, which is like 147 million kilometers. Okay, and if you take the other side from the sun to the other side, which is basically the farther side, there the distance is 15.2 crore kilometers, which is basically 152 million kilometers. That is the farthest. Now it is simpler. How many times it is nearest and how many times it is farthest? Only once nearest, one far. So we could say that our theory may be right if we go this way. Okay. So the nearest one is called perihelion, and this one is called aphelion. Okay, that are the names that they use. Okay. So now, is this theory correct? Is our answer right now? So since it is ellipse, nearest is actually summer and farthest is winter. We could have accepted this theory, provided we did not observe one very important information. So look at this information. The nearest is in January, okay, and the farthest is in July. So if our theory is right, January should be the hot middle summer. Is this true? No. So something wrong with this theory too. Let us carefully observe how actually the earth goes around the sun. Earth goes around the sun in a very peculiar way. Now let's look at this Earth. Okay, this is our Earth. If you keep the Earth straight like this, okay, and rotate it, this is how Earth rotates. This is called as the axis of rotation. I just put one stick here, the axis of rotation, around which it rotates. Now this axis of rotation, if it is tilted with respect to the plane of the movement around the sun, let's say it's sun here and it's going around, you carefully watch that animation, it shows very clearly how it is tilted with respect to the plane of the movement. That tilt is supposed to cause the seasons. If you watch carefully, when it comes on the left side, okay, now just keep watching here, when it actually comes towards the left side of the sun here, okay, you can clearly see that the light is lit up like this in this area. Okay. So the top portion, which we call as North Pole and around North Hemisphere is fully lit up very well. It's very near to the sun. Whereas when it is on the other side, bottom portion, the South Hemisphere and this area is lit up well. So what does it tell us? It tells us that there is actually summer. When there is summer on the northern hemisphere, there is winter in southern hemisphere. And there is winter in northern hemisphere, summer in southern hemisphere. In fact, this is true. If you actually go to Australia, there it will be winter when we have summer in the northern hemisphere. So this is the correct explanation. This tilt actually causes the seasons. So if you watch it I stop this and show you the picture. So on the left side here, when it is like this, you can see the light from the sun actually comes straight into the northern hemisphere. Okay, it's a straight hitting light. Whereas here to the Australia, the light is slanted, so it's not very hot. Straight, very hot. Okay, so it's summer when it is this side. When it is the other side, if you look at this, the sun from this side goes and hits it, and this side it is very hot, and this side slants sunlight, and it is winter. Okay, so the winter and summer are not same for northern hemisphere and southern hemisphere. It depends on whether the sun hits slantwise or straight, okay, obliquely or straight. And you can even see that the North Pole is always lit up. Even when it is turning like this, North Pole is always lit up. Our South Pole is always lit up. That tells us that it is 6 months of day and 6 months of night in North Pole and South Pole. For all the other places, days and nights are basically happening when it is rotating, not for the North Pole and South Pole.